Hello and welcome to the video. Before we get started, if you'd like to provide input on future content and get our weekly newsletter, click on our survey. The link will be below. We also have a report on Ethereum 2, along with a bonus report on why you should learn Solidity now. Again, the link will be below. Now on to the video, and thank you. Okay. So tonight we're going to talk about blockchain layers, and we might touch a bit on sharding or just talk about it again. We've talked about this with some of these blockchains, and it's kind of an important concept because it allows you to understand the differences between chains. Now, this was one of the blogs I looked at. Layer 1 is your basic blockchain layer. So that would be Bitcoin, that would be Ethereum, and it's focused on the, proof of, initially it's been proof of work, where you're just logging all the transactions. You got the immutable ledger, and of course, proof of work has the issue of using a lot of computing power. So, like Ethereum 2 is moving to proof of stake. And Solana, which is really becoming popular, is a proof of history. And we've talked about that in the past. Now, so that's your layer 1. Now, they do mention in this article layer 0, and that's our, like, your base layer, where they say like your hardware and the internet and the things it works on. Now, layer 2 is the way it's described is that's the subchain, the chains that come in and take some of the work, do some of the calculations, off the base layer. So the base layer does the main security, main ledgering. Layer 2 handles certain things. An example of that, and this is off of Solana, which is not a traditional layer 1 protocol because it uses the unique proof of history, but Metaplex. And what they describe it here, they increase scalability by essentially offloading things, smart contracts, different things on top of layer 1. So yes, they talk about smart contracts. Now, that could be an issue because, and they talk about this in the Radix stocks, because you can have siloing. One chain, the problem with cross-chain communication, as opposed to one chain where everyone can talk together. There are different, first of all, there are cases where the chain itself, this layer 2 chain, is its own thing, and it doesn't need to communicate with the other layer 2 chains. An example of that I would think would be Metaplex, because Metaplex is off doing its own thing, hosting NFTs and so on and so on. If someone wants, I think it's Agrave, the financial blockchain. If they want to turn around and start dealing with DeFi transactions, that has nothing to do with Metaplex. And let me see what that, AAVE, and I don't know when this article is from. It's from August. They're looking at potentially living as a layer 2 on top of Solana. Then they also talk about layer, let me see if I can find that. Here we go. Layer 3 is more of an application layer. So that would be more of the user interface that hides the other layers from the user. Now, this is analogous to if you looked at computer networking, and they talk about this in this particular article, Beginner Guide to Blockchain Layers, the OSI model. So if you've studied computer networking, you've heard about the 7 layers of the OSI. You got the physical structure, your layer 0, your data link. So that's the frames, the Ethernet, all the interconnected stuff. And then the network layer is your packets, your IP, ICMP, IPsec, etc. Then the transport is your end-to-end, your TCP. So that's the where you have communications that's end-to-end, as opposed to looking at the packets running around the network. Session is, they're saying sync and send support. So that's your APIs, your sockets. And then presentation is things that you're all probably familiar with. Certainly JPEG, MPEG, FTP, IMAP, if you use a lot of email works on that, SSH, SSL. And then finally at the top is your application layer, the end user, your web browser, your HTTP, your FTP, your internet relay chat, et cetera, et cetera. So this is sort of an analogy of the layer 0, the layer 1 being the underlying structure of the ledger. And then you have on top of that, you can have subchains living on that, such as your smart contracts or your Metaplex or whatever it may be. And then on top of that could be the API that hides everything else. Now think about this in terms of DApps, right? When you use a DApp, you go to a web page and you type stuff in and you upload something, or you make a transaction from your wallet or whatever the case may be. That is above the smart contract layer. So that's your user interface. So that would be like your application layer. So it's very interesting to see the analogy here. And what I hadn't quite thought of it that way, but when I saw this, I'm like, well, this makes perfect sense. Of course, that's what's going on. You have the Ethereum blockchain, and then it's doing its ledger thing, and also it has your smart contracts living on top of that. And then you have your web UI living on top of that, talking to the smart contracts. So looking at it that way helps you understand, and you can also understand some of the pros and cons and different things like that. Related to that, one of the things they use to speed up your layer 1 is sharding. And we talked about that. Basically, it does help because you're basically breaking the transactions. And we talked about that in terms of radix, where you have groups of validators validating different things, and they may not have to know about everything. They have to know about their particular group, and that's a big way that they try to make things faster on the layer 1. So in Bitcoin and Ethereum, everyone has to know everything. There is one ledger, everyone has to know the whole thing. When you get into something like a radix or let's see, I'm trying to think if they're giving you an example here. So that charting is used very heavily in radix. So
these are the ways that, and this is the way that the different chains are structured, and also with sharding, the way they try to make things a little bit more efficient. Because again, like we said the other night, Ethereum is really, really slow to the point that it's not going to work for something like if you try to implement credit cards on, and this is an example I heard, credit cards on, one of these older blockchains, it's just not fast enough. If you think of how quickly, um, you know, American Express or Visa has to do their thing and get those transactions processed, they're just too many. If you can only do, was it something like seven? It's very slow. Maybe it's 7 transactions a second or something. So that's something very important to be aware of as well. So hopefully this has been enlightening. I think this is another example that shows that we help you understand the different blockchains and the whole relationship between Solana and Metaplex, or what are the issues, again, what Radix is trying to solve, what are the issues that Ethereum 2 is trying to solve. And it does question, the thing with Bitcoin is it's what they call, well, in the US, they have a big football game, American football game on New Year's Day called the Rose Bowl. It's out in Pasadena, California, and it follows this incredible parade where people spend months and months decorating floats with flowers, and they call this game the granddaddy of bowl game because it was one of the first, if not the first. Well, Bitcoin is sort of the granddaddy of crypto. Now, whether it's can still or how it's going to adapt as things move along. A lot of people hold it because it is something that it existed. You're not betting on some new coin that you don't know what 100% what's behind it. That's why banks and institutions are more likely to get involved in Bitcoin than in some altcoin. But we don't know what the future holds with something like that, or how they're going to adapt to the future. Uh, like I said, Ethereum's trying to adapt. So anyway, hopefully this has been helpful and interesting. And for those celebrating, I wish you a very, very Merry Christmas tomorrow. And I will speak to you next time. Take care.